Vectors. In this video, first we will cover about the basics of vectors, that is how magnitude and direction information is being represented by a vector. Then we will be seeing about representation of vectors, how vectors are represented using the unit-based vectors I, j and k of the Cartesian coordinate system. Further, we will be seeing about direction cosines. Direction cosine are the cosines of the angle alpha, beta, gamma that the vector makes with x, y and z axis respectively. We will see all these in detail in the next sections, and let's get started. Vector is a mathematical entity that represents both magnitude and direction. The important words here are magnitude and direction. In the next section, we will see how vector represents magnitude and direction. Consider this xy plane and consider a point A having x coordinate 4 and y coordinate 3. The position vector of the point A is called a vector OA, and it goes from origin to the vector. The magnitude of the vector OA is the length of the vector, which can be found out by Pythagoras theorem. That is, it is square root of 4 square plus 3 square, which is root of 25, which is 5. The vector is represented as 4i plus 3j, which gives the idea of the direction of this vector. In the next section, we will see what these I and j are. I, j and k are the unit-based vectors of the Cartesian coordinate system. Unit-based vectors are having magnitude unity, so it is only having direction information. I vector is in the direction of the x-axis, j vector is in the direction of the y-axis, and k vector is in the direction of the z-axis. So these vectors represent direction information in the Cartesian coordinate system. Coming back to our vector OA, the representation of vector OA is 4i plus 3j. The magnitude of the vector OA that we have already seen is 5. The direction of the vector OA, that is the unit vector of vector OA, is 0.8i plus 0.6j. We will get the unit vector of any vector by dividing the magnitude with vector representation. Here 4 divided by 5 is 0.8 and 3 divided by 5 is 0.6. Hence, the unit vector of this vector is 0.8i plus 0.6j. Now, we will increase the length of this vector. The vector is now 8i plus 6j. The magnitude is 10, which means we have doubled the length of this vector. But here we can see that the direction, that is the unit vector, remains the same. Now also it is 0.8i plus 0.6j. That is because we have only increased the magnitude, but the direction of the vector is remaining the same. Now we will bring the vector back to its original state. Let us rotate this vector in order to align with the y-axis. The vector is now 0i plus 5j. The magnitude same, which is 5, but the direction has changed. So rotating vectors will not change the magnitude, but the direction will be changing. I hope all the viewers are understanding the concepts of magnitude and direction of vectors. Now we will reset our position back to A 4, 3. Now we will add one more point, point B minus 2, 5, and the position vector of this point OB will be minus 2i plus 5j. We will find the direction vector of point B with respect to point A, that is vector AB. AB will be having representation minus 6i plus 2j. We will also add another point, point D, having coordinates minus 6, 2. The position vector OD is minus 6i plus 2j. Now we can see that both the vectors AB and OD are having same representation. Why is it so? The answer is that both the vectors are having same magnitude and is having same direction. Since magnitude and direction are same, both the vectors will be having same representation. All vectors having same magnitude and same direction will be having same representation. Here we are having a three-dimensional Cartesian coordinates. Point A is having coordinates 3, 4, 5. The position vector OA is represented as 3i plus 4j plus 5k. 3 is the x component, 4 is the y component, and 5 is the z component of this vector. By this, we are coming to the conclusion of the current section. In the next section, we will be seeing about direction cosines. Direction cosines are another way of representing the direction information of a vector. In the vector shown on the screen, r is the magnitude of the vector, a is the x component of the vector, b is the y component of the vector, and c is the z component of the vector. Alpha is the angle that the vector makes with the x-axis, beta the angle that the vector makes with the y-axis, and gamma is the angle that the vector makes with the z-axis. Direction cosines are the cosine of these angles. That is, direction cosines are cos alpha, cos beta, and cos gamma. Direction cosines are denoted by L, M, and N, where L is cos alpha, M is cos beta, and N is cos gamma. From the highlighted triangle shown in the figure, cos alpha is A by R. A is the adjacent side and R is the hypotenuse. The highlighted triangle is in a plane that is having vector R and x-axis, and it is different from xy plane or xz plane. For angle beta, cos beta is B by R. B is the adjacent side and R is the hypotenuse. And for gamma, cos gamma is C by R. C being the adjacent side and R the hypotenuse. Now replacing these values, we can see that L is A by R, M is B by R, and N is C by R. R is the magnitude, which is root of A square plus B square plus C square. Substituting the magnitude will be giving the following equations. Here we can notice one property of direction cosines, that is L square plus M square plus N square is 1. That is the property of a unit vector, that magnitude of a unit vector is 1. L, M, and N are basically the x, y, z components of the unit vector. The point A, 3, 4, 5 is shown on the screen. The position vector of this point, vector OA, is 3i plus 4j plus 5k. The alpha, beta, gamma values and the cos alpha, cos beta, cos gamma values for this vector is being shown in the screen. Point A is changed from 3, 4, 5 to 3, 2, 1. The vector OA is now 3i plus 2j plus k. The alpha, beta, gamma and corresponding cos alpha, cos beta and cos gamma values are shown on the screen now. Viewers are kindly requested to check the values mentioned in the screen. So this comes to the conclusion of our video, and I hope everybody like this video, and see you in next video.